Good afternoon, everybody. Welcome to this week's CACOR live presentation. I am very happy to welcome back Paul Beckwith. He's been with us several times before. He's going to talk to us today about the good, the bad, and the ugly regarding the current climate chaos that we appear to be experiencing. We had a temperature today in New Delhi, India, of 52.3 degrees C, which is unprecedented. So over to you, Paul.
Yes, thank you to everybody at CACOR, organizers and members for having me on this program. So I'm going to talk primarily about a report which came out in December of last year called Global Tipping Points 2023. It's about a 500-page document that was released December of 2023 during the COP in Dubai in the United Arab Emirates. The lead author is Tim Lenton, who you may have heard of. He's with Exeter University, which produced the report. And it's all about, the global tipping points and what we face, if we pass these tipping points, and there's early warning signs that we're getting very close to passing a number of them. So my title is a little bit inverted. I should have called it Global Tipping Points, the Ugly, the Bad, and the Good, because that's the order in which I'll be talking about things. So the ugly, I would have to say, I call the mother of all tipping points. That would be the ocean currents, specifically the Atlantic meridional overturning circulation shutdown. Now, there's early warning signs in the strength of the AMOC. It's actually reduced up to 30% in the last few decades in strength. And if you look at the curve of the reducing AMOC, you can see a loss of resilience in the curve. So you lose high frequency changes. You get a critical, what's called the critical slowing down. The amplitude of the excursions from the norm increases. And this is a sign which is often indicative of a tipping in the near term. So basically cross the threshold and tip. Why do I call this the mother of all tipping points? Because literally almost all of the other tipping points on the planet and the Earth system will be affected by an AMOC shutdown. So what would happen? Well, basically Europe would go into a deep freeze. Northern Norway could experience a drop of up to 20 degrees Celsius. In the winters, we would be getting ice crossing the Arctic Ocean, extending over to Europe. Eastern Canada would get quite a bit cooler. It would drop up to 3 degrees Celsius. Most of Europe would drop 3 to 5 degrees Celsius. We basically wouldn't be able to grow food in the Northern Hemisphere to the extent that we do. This is a problem because almost all of the food grown on the planet, or the vast majority, is grown in the Northern Hemisphere. The heat doesn't just vanish on the planet, the heat is redistributed. So although the Northern Hemisphere goes into quite a bit of a deep freeze, the tropics significantly warms. And with the tropics warming, the monsoons would shift southward because the band of storms circumventing the equatorial region called the ITCZ, or intertropical convergence zone, would shift southward. So the monsoons that are vital for supplying water to literally billions of people and to grow crops in those regions would be a problem. The Southern Hemisphere would also greatly warm, and we would lose tremendous amounts of sea ice and have accelerated melting of Antarctica. Well, guess what's happening right now? The Antarctic sea ice has been plummeting off a cliff basically since about 2015 or so. So the AMOC shutdown is a real wild card because it, we expect with the Arctic greatly warming, the jet stream slowing and becoming wavier, more and more extreme weather events occurring, all of these, and people are worried about Greenland shedding vast amounts of ice, but all bets are off if the AMOC shuts down, basically. And the AMOC has already, the reduction of the AMOC by, I mentioned that 30% already hasn't had a large effect on the Arctic. So there is a study recently which shows that the Arctic sea ice would have probably already completely gone had we not had that cooling effect from the AMOC reduction. So that's something to think about. Now, the bad, of course, you're familiar with a lot of the Earth system components that are bad, like Greenland ice cap melt, Antarctic ice cap melt, the Amazon, loss of a lot of the Amazon rainforest and conversion to savanna. We've seen climate change or global warming accelerate significantly in the last number of years, in the last decade, particularly. If you have a chance to read David Wallace Wells' book, Uninhabitable Earth, he talks about how many parts of the Earth will become uninhabitable to people. Up from 1970 to 2010, the planet experienced 0.18 degrees Celsius of warming per decade. From 2010 onward, James Hansen was predicting an increase of 50 to 100%. Well, it's been more like 100%. So we're at about 0.36 degrees Celsius per decade over the last decade. And if you take just the last few years, we're closer to 0.48. Of course, nobody lives in an average climate or experiences a global average temperature, right? Us land lubbers, live on the land, which is warming at double the global warming, the average global warming rate of rise. If you live at altitude, elevation, you could have another doubling. If you live in the high latitudes, you could experience 4 to 6 times the rate of warming than the global average. And, it's been mentioned that parts of the tropics are baking now, over 50 degrees Celsius in Pakistan and India. At this rate, the only way for people to survive outside will be with, I call them chill suits, water-cooled suits, or there's a company in India that uses thermoelectric coolers, an all-solid-state device with a battery pack to cool people down that are working outside. So all of these things are happening around the planet. The other factors that are occurring, of course, locally in Ottawa and this region, we experienced the derecho 2 years ago, which did tremendous tree damage. If you're driving to Toronto and you go Highway 7, you can see along that route, swaths of trees that were down 2 years ago, and it looks like it just happened yesterday. Of course, the tornadoes in the US have been going crazy. That's been on the media radar recently. They have about 1,200 tornadoes each year in the US, and that number hasn't changed significantly. Of course, if I asked you what the second leading country was for tornadoes, I don't know if you'd guess Canada, but we have about 100 a year, 3 of which we had in the Ottawa region just a few years ago. Some other things that have been in the news recently, climate related, are the planes basically going along, seeing nothing on radar, and then experiencing what is called CAT, or clear air turbulence, where they basically fly into a void and plummet several thousand feet. Many people injured. It's happened on at least 2 or 3 flights now. So there's all of these sort of things that are happening that are, we could have maybe thought they're unexpected, but if you're really following the science, it's not so unexpected. The largest city in North America is going to be out of water basically in a month or so if the present drought and heat wave continues down in Mexico. So we're talking about Mexico City, of course. Mexico hit the news recently for monkeys that were basically just dropping out of trees, dead from heat stroke, heat exhaustion. So some other bad tipping points are human related, of course. So as you get uninhabitable regions of the planet, this forces more and more migration of people. And when you get vast amounts of migration of people, then countries that take in these people, their services are swamped, and politically, we tend to end up with getting right-wing governments in these countries. So just let the phrase second term President Trump, just picture that in your mind, because that is a possibility, a very likely possibility. I would argue that Biden has jumped the shark in Gaza. I'm not going to get political, but I do want to just say that we seem to be experiencing a big breakdown of global and social order when we have Western countries ignoring ICE International Criminal Court rulings, or taking them in some cases and ignoring them in other cases. It doesn't send a good message that all is well in global international politics. So we're looking at a collapse of global order in society and civilization. When this happens, you get a culling of the weak first. So, each country has different resilience to global issues and to heat waves and to climate change and to perhaps, loss of food supply, access to fresh water, access to food, etc. We've experienced a massive flood of fake news and propaganda with our social media networks. It's becoming much harder to tell what is the truth and what is not. So these are all bad things that have a strong climate change connection. I call it abrupt global climate mayhem, if you like. Good things. Okay, let's talk about good things, because there are good things that are happening. So we can all go to Mars, right? I don't think so. But solar photovoltaic has experienced accelerated growth, huge accelerated growth year over year. Wind power, both offshore and onshore, is growing in leaps and bounds. Battery technology is improving all the time with new materials, maybe that aren't with less of the sort of blood materials or blood minerals that are obtained with almost slave labor in Africa. I'm thinking cobalt in particular. Electric cars are greatly on the rise, but think about what we want to do with electric cars. I mean, there's about 1.5 billion cars on the planet. Okay, 1.8 billion people, 1.5 billion cars. Of those cars, the number of those cars, by the way, is almost the same as the number of livestock on the planet, cattle, cows, etc. And of course, both of these things have a massive impact on climate change and warming. So when we talk about the electric car revolution, have we really thought about, we certainly don't want to replace 1.5 billion gas-powered cars with electric cars, right? We don't have the minerals and the resources and stuff to do that. Surely we need to change the way we do things. Your car is a very easy one. It sits in your garage 95% of the time, right? So why do you need a personal car? I think we need to do away with personal car ownership. We could have about 10%. We could replace, as we phase out that 1.5 billion gas-powered cars with electric cars, we could certainly do with only 5 or 10% of the total number, and that would be sufficient for people. There'd be no traffic anymore to speak of. There'd be a lot of space that could be reclaimed. It would solve the housing crisis as garages were turned into apartments. Just think about some of the benefits, but try to pull a car from an American in the Midwest or something. You're gonna be face shotgun blasts if you try to do that. So the idea of personal freedom and public, personal ownership of vehicles is a tough one to surmount. But if we were to go to full self-driving electric cars, you press an app on your phone, the car is there within 30 seconds or a minute in a city, and away you go, and it takes you where you want to go. Why would you need to own a car, right? So, and the car manufacturers, of course, would lobby to death on preventing this from happening. Look at the cheap Chinese, inexpensive Chinese electric car. The US is already paranoid and putting 100% tariffs on that. So public policies, of course, are very, very important, and can make things worse or can help things improve. Another bad thing is actually the equilibrium climate sensitivity is much larger than we think. So the equilibrium climate sensitivity is how much, what the CO2 levels equivalent would need to be in order to double the warming above pre-industrial. The number that Hansen says is 3 or 4.5 degrees, plus or minus 1.5. So that takes us up to about 6 degrees Celsius. The sensitivity is probably much higher than the IPCC and mainstream science is saying, because we're finding out that the aerosol effect is much, much stronger than we originally thought. Hansen's been talking about this for quite a while in his work. Now, I'll get back to this in a minute, but basically climate policy now has shifted significantly in the last few years. You hear the term net zero all the time. Net zero means carbon removal from the atmosphere ocean system. Maybe call it CDR for carbon dioxide removal, but also methane removal. So in order to get to net zero, if we had these magic technologies to remove vast amounts of carbon from the ocean atmosphere system, whether it be direct air capture or other means, natural means, perhaps, then as long as that exceeds emissions, we can bring down the existing levels of carbon in the atmosphere. I've often talked about the three-legged bar stool in the past, where we need to slash fossil fuel emissions as one leg. We need to remove carbon from the atmosphere ocean system. Might be easier to remove it from the ocean rather than the atmosphere because it's more concentrated, but it is in dynamic equilibrium. So if we removed it from the ocean, we would reduce ocean acidification at the surface immediately, and there would be more exchange of more carbon, CO2 coming out of the atmosphere into the ocean. So it doesn't matter if we remove it from the atmosphere or ocean, it's going to go down in both if we manage to do that. The third leg of this bar stool is the still controversial, and it's getting less controversial, I think, but I'm talking about solar radiation management, SRM. I prefer to use the term SOS for this technology, standing for solar optimization or optimizing strategies or systems. So solar optimizing systems. And because the aerosol effect is so much greater than we anticipated, this effect, the good news is that this would, if we did it right, this would be a very effective way of cooling the planet, giving us more time to get our act together and pulling us away from these massive tipping points. So how do we know the aerosol effect is so large? Well, Hansen's recent work, if you haven't seen it, go Google James Hansen, Columbia University, go to his website and look at his recent articles and letters. He talks all about the International Maritime Organization reducing the amount of sulfur by regulation from shipping fuels for commercial ships around the planet, most of which ply their routes in the Northern Hemisphere. So the IMO removed sulfur concentration in shipping fuels from 3.5% down to 0.5% was their latest strong regulation. That happened in 2020. In 2015, they brought it down to the 3.5% from about 7 or 8%, I believe. Now, so Hansen is showing in his work that the ocean temperatures in the North Atlantic are much, much warmer because of this reduction of sulfur in the shipping fuels. Now, there's very important corroborating work and actually work preceding, because China underwent a massive reduction of air pollutants between 2006 and 2017. So they regulated and achieved a reduction of sulfur dioxide coming from Chinese factories by a staggering 70% between 2006 and 2017. They reduced black carbon by 29% and organic carbon by 41%. In 2015, 2.5 million people died from air pollution in China alone. So this became a national priority. And what has happened is a paper was published in 2020 detailing exactly how this reduction of this cleaning up of China's air caused climate to change in the Northern Hemisphere and also in the globe. So basically what happened is the jet streams, of course, wind patterns move from west to east in the Northern Hemisphere. So with China cleaning up their air, they got rid of all of these little tiny mirrors, if you like, the SO2. The SO2 levels peaked in 2006 in China. Now India is the biggest producer of SO2 in the air pollution, but the SO2 has two strong effects on radiative forcing. The amount of sunlight that hits the earth depends on the sulfur dioxide in the atmosphere, because the sulfur dioxide acts as little tiny mirrors which reflect sunlight, allowing less sunlight to hit the earth, so it cools. This is a direct effect, which is quite large, but even much, much larger than the direct effect is the indirect effect. The sulfur dioxide in the air acts as little cloud condensation nuclei. So water vapor condenses on the sulfur dioxide. The water builds up. You get these little water droplets. The little water droplets create these very highly reflective low-level clouds, reflect a lot of sunlight, and cool the planet underneath, cool the surface underneath. And this is a huge effect. So combined, these two effects have caused significant removing the sulfur dioxide from China's air caused a tremendous warming over China, because you could get a lot more solar radiation being absorbed by the surface. The extra warming over China and over the Pacific Ocean downstream of China caused increased evaporation. So there's more water vapor in the atmosphere, but the water vapor, instead of condensing on vast amounts of sulfur condensation nuclei, there were much fewer condensation centers for it to, so it became concentrated more in certain regions. So the net result was there was a huge increase in precipitation over China and over the Pacific Ocean. Okay, so what we're seeing is basically these marine heat waves that we've been getting in the Pacific Ocean, especially off Alaska, which have been hugely detrimental to marine life. Temperatures of the sea surface being up to 3 degrees Celsius warmer than they would be otherwise, have now been directly attributed in a paper that was just published a few weeks ago to the reduction of sulfur and reduction of air pollutants in China. Okay, so the whole climate system is extremely sensitive to these aerosols. Now, we can't blame China. They're just trying to reduce the number of people there that are dying from air pollution. We can look at what the US did with their sulfur dioxide reduction, putting scrubbers on smokestacks, etc. We can look at what Europe also did with their air pollution reduction measurements in decades previous. And we can go back and we can see the huge effects on the planet that occurred from these reduction programs, which people haven't really thought about, and there hasn't been much study done on that. But when the US greatly reduced air pollution, that meant that the air moving over the Atlantic Ocean was more pristine, so that solar radiation much more would get through to heat up the oceans than would when the pollution was occurring. So the Atlantic Ocean experienced tremendous warming after the US cleaned up their air. Also, when Europe cleaned up their air with their scrubbers, etc., it greatly cleaned up the air that was being carried over to China and then over to the Pacific. Now, all of these programs have had a major effect of causing warming in the Arctic. So this cleaner air has greatly accelerated and increased the warming of the Arctic, contributing to the Arctic temperature amplification. And as I've said ad nauseum in previous talks, etc., this great warming of the Arctic has slowed the jet streams and made them wavier and get stuck. Meteorologists call it a blocking. And then we get a great increase in extreme weather events and the frequency of them, the severity of them, the duration of them, plus they happen in regions where they never happened before. And we got bizarre things happening like snow in the driest deserts of the world, etc. So basically, the climate system is very complex. The aerosols throw a huge wrench into things. Also, if the AMOC continues to slow down and passes the threshold and collapse, then all bets are off on what this planet will look like in, say, a decade or so. What is the international bodies? What are they doing? The IPCC, Intergovernmental Panel on Climate Change, they're still running the yearly climate conferences. The climate conferences seem to be occurring lately in countries that are huge fossil fuel producers, like the United Arab Emirates, and it's in Azerbaijan, in Baku, and the president is used to be the president of the COP, used to be the president of the national oil company there, similar to the president of the last COP in Dubai, was the president of their national oil company, etc. The IPCC is just making a call for and starting the AR7 cycle, Assessment Report 7. So in 2021, the first document of the AR6, Assessment Report 6, came out, called Working Group 1 on the Physical Science of Climate Change. That was followed by Working Group 2, Adaptation, and then Working Group 3, Mitigation, about 6 months later. And only last summer, which is a full 2 years after the initial Working Group 1 report came out, did we have the final synthesis report come out just last summer. I'll do a video on that soon. So the AR7 cycle, the first document, the Working Group 1, is expected to come out in late 2029. Okay, and they're going to have an interim report on climate change in cities coming out in a couple of years. But basically, you can see that this whole process, nothing is changing. Like it's like bureaucratic dinosaur. It'll do this. Literally, I think I added all the pages of all the Working Group 6 or all the AR6 cycle reports, and it comes to almost 6,000 or 7,000 pages. I mean, who's going to be reading this stuff anyway? So anyway, that's where we have international climate negotiations at. So I think I've I've talked for about half an hour. I think I'm sure there's lots of questions, and I think we should start going to questions, and I can go into more depth on any of these things that I've talked about.
Great. Thank you very much, Paul. I'm going to ask a couple of questions, actually, as your host, and Claude Buechner is on deck with the next, just a minute, making a note here, James. Okay. So kind of in reverse order, do you know whether science has established why there was approximately a 2-year delay after they stopped the use of high sulfur diesel fuel in ships, especially over the North Atlantic? We did not see an immediate increase in temperatures. Why the delay?
Well, it's it's a good question because I guess the problem is in the real world, it's hard to see immediate cause and effects because there's lots of other factors coming in. For example, we have global climate variability in the ENSO cycle, the El Nino Southern Oscillation cycle. So during the El Nino phase, the winds, the Walker circulation, which is winds, which causes the trade winds, slows down, and you get water sloshing from the Western Pacific to the Eastern Pacific off South America. And that heat shelves and comes to the surface and gives the atmosphere lots of heat. This is the typical El Nino cycle. And then the La Nina is the opposite phase where those trade winds are stronger and that wind is kept in the West Pacific. So we have, there's a lot of, there's climate variability from that going on. There's also the sulfur is being produced on land by industry, and we've made great strides in reducing that. There's also the sulfur that is in the shipping fuels, which is being regulated to be reduced, but it hasn't been completely eliminated. So this paper on China, which shows their reduction from 2006 to 2017, well, they're still continuing their efforts to get rid of all the sulfur. So there's been simulations done on the effects on the Pacific Ocean from China. And if they manage to get rid of all, like they compared what is there's these huge climate model intercomparison projects, they call them CMIPs, and they have in CMIP 5, that version, there was they assumed more or less flat amounts of sulfur from China. In CMIP 6, they put in the actual data of the reductions in China, and then they looked at the difference from all those model results, so they could attribute so much warming and so much increased precipitation to what they did. And if they get rid of all of their sulfur and pollutants, there's going to be tremendous increases of rainfall. I'm talking about up to 200 millimeters per year over parts of China, over parts of the Pacific, and also warming up to about a degree, over a degree or more over specific regions of China. So you've got all of these sort of things going on. There's also volcanic activity puts up a lot of sulfur dioxide in the air when there's volcanic eruptions. We went through a period of time where industry really throttled back with COVID, right? So industry really throttled back. Carbon emissions were much, much lower from 2000, 2001, but also the particulates, the aerosols going to the atmosphere were much, much lower. So the thing is it's a complex because we have these two competing effects, right? The greenhouse gases cause the long-term warming, cumulative warming. The reduction of the aerosols causes a very rapid reduction of sunlight being blocked. So a great increase of warming. So we've got these competing effects going on different timescales. So it's with all of these factors, it's a bit difficult to know exactly. I'd have to look at the specific location because there's a big regional difference in what's happening.
Right. Understood. In fact, I think I saw a map that showed that the North Atlantic is one area where we're not quite experiencing the level of warming that we're seeing in other areas.
Yes, precisely. Yeah, this is called the global warming hole. And Stefan Ramsdorf has talked about this a lot. If you're on X/Twitter, make sure you follow Stefan Ramsdorf and have a look at some of his past tweets. He's done whole chains on why we have this global warming hole. It's an area south of Greenland. The reason is being attributed to the slowing of the AMOC. This seems to be a sign that the AMOC is slowing and there's less heat being brought across in the Gulf Stream, across over to Europe already. So that anomaly, that would cause a negative temperature anomaly, or a global warming hole where you get cooling instead of warming. It's the only place on the Earth that we've seen cooling, really.
Also, probably the injection of the fresh meltwater, which is at quite a low temperature coming off the Greenland ice sheet, would contribute. I wonder if I could go back for a second. You said 2000, 2001. I believe you may have meant 2020 and 2021 when we had lower amounts of industrial activity because of COVID.
Oh, sorry. Yeah, of course, 2020.
Yeah, okay.
It wasn't 20. Yes,
Yeah,
2020.
okay.
Industry. I
Yeah.
mean, you can look at the drop in emissions in 2020, 2021.
It's visible in virtually every country.
So the emissions, not just the emissions of CO2, but the particulate matter, and the sulfur dioxide was greatly reduced, the emissions from that, and that has an almost immediate effect on the planet, because if you're not producing those particulates, they're rained out within a week or so. So there has to be a continuous source for them to be up in the air.
Yeah, that was the original source of our acid rain problems back in the 70s.
Yeah, exactly.
Clarification, if you would. Sulfur dioxide and sulfate. I believe sulfur dioxide is a colorless gas which gets injected into the air, reacts with water, forms sulfates because it forms sulfuric acid and that ionizes. So as far as I knew, it was the sulfates that are largely responsible for the reflection of sunlight. Does sulfur dioxide itself actually reflect sunlight, or is it really the sulfate that we're concerned with?
Yeah, you got me there on the chemistry. I thought it was the because SO2 is a gas, as you say. Yeah. So it has to be chemically reacting to form some sort of little grit particle, which is super small. So it doesn't fall from gravity quickly. It basically swirls around in the atmosphere, attracts water vapor, which is a gas, right? The water vapor condenses on it, forms these little tiny droplets. And if you've got, by the Twomey effect, if you've got loads of little tiny water droplets, it's highly reflective. That'll be the bright white clouds that you see as there's collisions between the water carrying, between the small water droplets. They coalesce into bigger and bigger droplets. The clouds get darker, and if you see a storm cloud coming, it's very dark, it's carrying a lot of rain and you're going to get soaked. So it's a whole sort of process of how, but the very small water droplets, if there's loads of cloud condensation nuclei, not only are they very bright and highly reflective, but they're much longer lived than the larger the clouds that have larger droplets. Because the ones with larger droplets, of course, gravity has a stronger effect. They're much likely to those droplets to fall to the ground as rain, as opposed to swirling around because they're super small. So Stephen Salter talked for many years about some ideas on what he called marine cloud brightening. Taking seawater and firing it through nozzles with high pressure pumps to produce little salt crystals, which would then attract water, forming low level clouds that were very bright and could reflect sunlight and cause some cooling of the planet. And he devoted his entire life to this. He was at University of Edinburgh and an emeritus professor, and he passed away just a few months ago.
Cool. Okay, I wonder if you read recently about some people reanalyzing the 1850 to 1900 baseline temperature and finding that we were probably estimating it at about 0.25 degrees C too high. And if that's in fact the case, their argument was we probably already have passed the 1.5 degree target that people had in mind at Paris.
Yeah, so the baseline issue is a very important one because if you go back into the history of the IPCC documents, the initial reports and documents and climate conferences, when they were starting to talk about the 1.5 Celsius as a threshold and 2 Celsius the original baseline was 1750.
Right.
Well, the baseline was the start of the Industrial Revolution,
Right.
which was the year 1750.
Yeah.
Now the baseline by default, by assumption, is 1850 to 1900. And if you look at the difference between the year 1750 and that 1850 to 1900, you get 0.2 or 0.3 degrees Celsius. If you just go into the curves and eyeball them, you say, yeah, it's 0.25 or 0.3. But there is some studies that show, well, maybe it's not as high as that. Maybe it's 0.15, you know. But the point is there's already been warming, significant warming, or noticeable, measurable warming since 1750 and the baseline. So when you talk about those temperature targets, yeah, you could argue, there's an argument that you can add 0.2 or 0.25 to the temperatures that we're saying now as being, you know, and we're already well over 1.5. Now, that being said, if you take the 1850 to 1900 baseline, for 2023, we surpassed 1.5. And if you take a rolling average, as of a month or two ago, we were at 1.7. You know, as the El Nino tapers off, which it's doing, you know, we might drop to 1.4, 1.45, but you know, so then the question is, when you talk about these temperatures, are you talking about passing, you know, how long do you have to pass 1.5 to say 1.5's done deal? It's in the rearview mirror. You know, we've already had over a year in that situation. If people argue, well, you need a climatological average, we need to be over that for 30 years, right? Then that, I mean, things like that are never explicitly stated when we talk about those numbers. So, you know, most people would say, okay, I mean, the thing is we're likely to be over 2, you know, within the next decade, right? So we still going to be saying, well, we're not really over 1.5 because we haven't been over it for 20 years or whatever. So, you know, to be over, do we have to wait 30 years to say that we're over those numbers? I don't think so, right? So
well, if the changes in the system are profound over that period of time, you don't have 30 years to wait.
Exactly. Yeah. You know, we'll be trying to grow food in the Northern Hemisphere.
Okay, now to get to my big question before I get to Claude, and I have 4 others in line after him, including James, by the way, who didn't come into the chat, but did put up his hand. Okay, I'm still looking for the source of this video. It was on Twitter, X. And I have asked the person who posted it for his source because he was not the person who produced it. There was an atmospheric scientist on there talking about the fact that he's actually not too concerned about the actual temperatures and not too concerned about global warming, which he found is a term he doesn't really like because it gives you the sense that it's happening slowly, but rather a complete shift, to paraphrase him, in the climate system, where he thinks what will happen is a complete disruption of the current oceanic and atmospheric currents and a evening out of temperatures between the poles and the tropics, which will, for all intents and purposes, stop the circulation in the atmosphere, which helps to drag along the circulation in the oceans. And basically what he was saying is, all bets are off. No idea what the heck is going to happen after that. We've never had that on Earth.
Right. Okay. Well, the thing is, we have had that similar. We have had the AMOC shut down many times in the paleo records, right? And we call this, the term is Dansgaard-Oshur oscillations occurring, where the AMOC shuts off, stays off for 100 years, 200 years, and it restarts. Then later on, you know, 1,000 years later, it shuts off again for a couple 100 years and it restarts. And there's a cycle that continues. And then the very last part of the cycle, we get this massive ice rafting of glaciers crossing the Arctic Ocean into the Northern Atlantic, going over to Europe, like the bond cycle sort of is. So there's different terms in paleoclimate. So again, I would say that probably the world expert on this sort of thing, I would have to say, is Stefan Ramsdorf in Germany. I think he's with the Potsdam Institute still. And he's very active on Twitter. He's a really nice guy. I've met him at a number of different conferences, etc. And he seems to have a handle on this, probably as good as anybody else. It's well documented in the Tipping Points report, which Tim Lenton authored at Exeter University. There's whole chapters on this sort of thing, which gives all of the sort of the history and the science and the paleo records, what happened then. And we're actually, I'll be doing a video on my channel, probably my next or the one after next, on the AMOC, the early warning signals that we've been seeing. So we're actually monitoring the oceans quite well with the Argo floats, which descend down to depth and pop up. We're measuring, we have a record going back several decades on the amount of water flow in Sverdrups past 26.5 degrees north. There's anchored buoys across the Atlantic, so we've got data on that. So I'll talk about some of the changes in the data on ocean flow, and how we're seeing critical slowing down in terms of that data. It looks like the frequency of oscillations and noise is slowing down, and the excursions are getting larger. And this is a sure early warning signal that the thing could be ready to tip. So I'll be talking about that. There is lots of, it's an area of very, very active research. There's papers coming out generally every month, at least, on the AMOC reductions.
Cool. Okay, thank you. So Ray Lurie is on deck, and I'm going to go over now to Claude Butner.
Thank you, Paul. My question actually is about the AMOC, and would the decrease or stopping of the AMOC result in vastly increased atmospheric storms as the Earth attempts to equilibrate among the zones with high temperature differences? And you've touched on this a little bit. Has this been well modeled? So
yes, yeah, it stands to, so the jet streams exist because the poles are cold, the equator is warm. So with the greatly warming Arctic that we've seen in the last number of decades, right, the jet streams actually slowed down in the east-west direction. It's become much wavier, and getting stuck in place, often causing these extreme weather events. So if the AMOC shuts down, then the Arctic gets much, much colder. So that would increase the strength again. That would increase the temperature difference to the tropics, right? The heat doesn't just disappear off the Earth. If the Arctic is getting much, much colder, then the tropics are getting much warmer. The intertropical convergence zone moves southward. The Southern Hemisphere warms up significantly. And the temperature difference to the Arctic greatly increases, so the jet streams get much stronger and straighten up, are much less wavy. Okay, so it could actually cause that could actually cause a reduction of extreme weather events that we're seeing in the northern hemisphere if we're not too far north, like sort of mid latitudes.
And a follow-up comment, my interest actually is the melting permafrost and release of carbon dioxide and methane. Would the temperatures be enough to stop that melting that is currently going on?
Yeah, exactly. We wouldn't have to worry about Greenland ice calving and about sort of the methane bomb going off in the Arctic, because the Arctic would go into a chill. And we're talking about a chill. Eventually, it would warm up from the overall, climate change signal, more greenhouse gases, but that could take, if the AMOC shuts off, it could be off for, in the paleo records, it's been off for, and restarted after a century or two. So we're talking about, if the Arctic if the AMOC shuts off and the Arctic goes into a deep freeze, we're talking about possibly a century type event. So we wouldn't have to worry about methane. And most of the methane concern in the permafrost is in the Northern Hemisphere. Right? We don't worry so much about methane in the Southern Hemisphere. So yeah, so all this stuff, like you know, all bets are off, really. I mean, the system is very you know, the AMOC shutting off would change our planet in extreme ways, and a lot of things we expect to happen would no longer happen, not in the short term.
The leading indicator is this anomaly of cooler temperatures up in the northern Atlantic to watch.
Well, that's an observation that has been directly tied to the slowdown. So yeah, watching that global warming hole, if it gets more exacerbated, stronger, that's probably a good sign. If the measurement buoys that are tethered to the ocean floor, the Argo float, show it shutting off, I would look at the temperatures in Northern Europe. Like if they significantly change. I mean, we're seeing some sort of effects that it's hard to explain. Like, for example, the UK has been quite a bit cooler than you would have expected in the last year and a half. They've had record amounts of rainfall as a result, right? So they're wondering like what's going on there, for example. So I just think that it's important to keep the AMOC in the back of your mind because it's such a significant effect. But then also, I mean, the aerosol effects are also very, very important, much more important than we would have thought before. So, I mean, James Hansen's basically saying that the doubling of CO2 equivalent on the planet will cause much greater temperature rise and warming than mainstream science says, because the aerosol effect is also much, much higher than mainstream science has said. So if both things are much larger, then that leads us to improper conclusions about what those both parameters independently are. And the problem is we don't have enough monitoring from satellites of clouds, right? Clouds have always been the wild card. And if you look at the aerosol effect on warming, the indirect effect, which is the clouds as opposed to the direct reflection from these aerosols, is, I think it's a factor of 6 times higher, the cloud effect. It's much, much higher. You think of these little particles as little mirrors, right? That's only like, 10, 15, 20% of the whole warming effect. Most of it is the clouds, the cloud condensation nuclei and the cloud effect. So we can actually detect the numbers of clouds over the oceans from satellites. And we've seen a huge reduction of low-level clouds over the ocean. Right? So, we're getting all of this direct evidence. At some point, the IPCC and mainstream scientists are going to have to say, well, yeah, I mean, Hansen's been right all along. I wouldn't bet against James Hansen.
Yeah.
Okay. Thank you so much.
Great. Okay. So Bill Reese is on deck, and we're going to go to Ray Luridown.
Hi, Paul. Thanks very much for a very interesting talk. The first question I had actually had to do with the global warming hole, which you answered already, but I want to take the opportunity to just clarify something you said. So sulfur, you're saying, is washed out of the atmosphere fairly rapidly, correct?
Yes, the particulates are, yes.
Okay, so one of the things, back when we had this debate about acid rain and sulfur, there were some measures taken to scrub some of that sulfur out of emissions of various plants and all that. My understanding is we're still emitting quite a bit of sulfur. Do you have a sense of how that would have changed?
Yeah, there's I've just been actually looking. I've been researching some papers. So I've got the paper from 2020 on China and what they've been doing and the climate effects from that. So then that got me to dig a little bit deeper into India and what their emissions are and what they're trying to do now. And then I started looking at North America and at Europe. So I'm still sort of at that sort of phase because I want to, once I learn more about the climate effects of our reductions of sulfur in North America, which happened, of course, with the acid rain thing. I mean, we put basically scrubbers on smokestacks to pull the sulfur out so it wouldn't go up with the rest of the emission products. And we also tightened up emissions from the cement industry and other heavy, steel industries, et cetera. But mostly the reduction of the sulfur was for the acid rain problem, and it was, both in the US and Canada, right? And then Europe did the same sort of thing. They followed suit. Once we developed technology for scrubbers, et cetera, Europe just went and used the same things to reduce their sulfur emissions. I do know that sulfur emissions from China peaked in 2006. I know that it's mostly the sulfur emissions that caused the air pollution, which killed, 2.5 million people. But it's also the PM 2.5 particles, which are very deadly for people because they get lodged deep in the lungs. But I couldn't tell you, whether North American emissions are 10% of what they were at the peak, or 5%, or 20. Like, I don't know those numbers, but it's very good questions, because when we cleaned up the air in North America to defeat acid rain, killing lakes, we caused a temperature rise in the Atlantic Ocean, and we caused an increase in precipitation over North America, and we caused an increase of precipitation over the Atlantic Ocean as well. And, the effects were largest, but then that would have carried over to Europe as well, because if you just go to Earth Null School, go to 250 millibar hexapascal height, look at the winds, look at the jet streams, look at how, the wind patterns are all, just look at what's downstream of where the aerosols are being produced. When they're not being produced, it affects things closer more so, but then there are long range teleconnection effects. So the same thing happened, with China. The timing is perfect for Chinese reduction of, and they could do it at a tremendously rapid rate because of the communist system, right? They just say to factories, you cut your sulfur 50%. I don't care if you have to reduce production 50%, but you cut it, because, they had this very strict policy and they achieved their objective. I mean, 70% reduction. Yeah, I don't see us being able to do it that quickly in a free society, in a Western society. So then, Europe went and did the same thing. So you can see, I mean, India is working hard now on that reduction. And if they succeed, then you can see that it's going to affect downstream, the ocean temperatures and rainfall and precipitation. But there's a very clear effect. You reduce those aerosols, you cause greatly increased warming, which causes greatly increased evaporation, which means more water vapor in the atmosphere, but there's less cloud condensation nuclei. So there's more precipitation, significantly more precipitation over the areas where you clean up the air, but also downstream.
Okay, thanks a lot.
Great, thanks. Okay, so James Desmond is going to be on deck, and we're going over to Bill Reese. Bill, you had a number of comments and questions, so take the floor as long as you need it.
Yeah, most of my stuff has actually been comments, but maybe I do want to explore one of these a little bit. We're focusing here on climate, and I want to make clear, I believe that climate change, global heating, is a horrendous problem. But it's an example of reductionist thinking, because climate change is just one co-symptom. You've all heard me say this before, of a much greater problem, which is ecological overshoot. So biodiversity loss, soil and land degradation, tropical forest loss, and all of this stuff, these are all co-symptoms, along with climate change, of the real problem, which is overshoot, which really means too many people consuming and polluting too much. Now, it's an important distinction, because when we focus on any one of these problems in isolation of the real cause, we get nowhere. And I posted a couple of things here. The point is that politically acceptable solutions to the heating problem have failed utterly to produce any results that are significant, at least in the sense of reducing climate change. We've had 32 years since the UN Framework Convention on Climate Change. In that period, Fossil fuel use has doubled. Emissions have gone up by over 60%, atmospheric concentrations. And in general, we're going backwards. So an argument is coming up in the political science literature that, in fact, this is a purposeful distraction by the corporate sector and the political process to defuse the environmental movement and attention to population problems and overconsumption. And instead, we're seeing a redirection of attention toward the climate problem because it means massive capital investment in wind, solar, EVs, non-existent carbon capture, and all of that sort of thing. And all of these techno fixes are being sold to the public on ground right here in Canada. Massive job creation, huge potential for economic growth, and so on and so forth. This is the cause of the problem. So everything we're doing by isolating climate and focusing on climate is not only not fixing the climate, but it's worsening the real problem, which is ecological overshoot. Too many people consuming and polluting too much. So I included one quote here from Clive Spash, who wrote in a paper I also gave to you, disaster policy is being designed to serve the capitalist growth-based economy so that the latter becomes the solution to, or at least becomes seen to be the solution to, rather than the cause of the problem. So I just wonder, Paul, if you have any response to that perspective.
Yeah, I mean, I agree completely with you that this is climate is creating strange weather patterns which are right in your face now. So I mean, look at tornadoes, for example. They used to be mostly confined to Tornado Alley, because you'd have the clash of cold air coming from west to east, crossing the Rockies, very dry, cold air. You had the warm, moist air from the Gulf of Mexico. They kind of meet. There'd be a dry line, and there'd be all kinds of formation of tornadoes in Tornado Alley. Those areas weren't very heavily populated. But now, if you look at the distribution of tornadoes, Tornado Alley has spread out to cover a vast region of the US, mostly the areas of Tornado Alley eastward and northward into heavily populated areas, and the storms are occurring in clusters. So although you may not have more tornado days, when there's a day of tornadoes, you might get dozens or even 100 storms. So the heat waves are affecting more and more people around the planet. There's threats to global food supply. So it's becoming in your face of the average person. Cities are becoming almost unbearable temperature-wise in many countries. If we run out of water in Mexico City, what's Mexico City, 20, 30, how many millions of people live there? So it's becoming very much more of an urgent thing, but I agree completely with you that it's all part of this bigger problem of, how we're doing things on this planet, like the overshoot. I mean, what is it? The book called Overshoot is, what is it? Philip can't. I don't remember.
William
Catton. That is an incredibly good book, and that's
it's 30 years old.
Yeah, exactly. It explains things perfectly. I have a copy of it. It's a great book. Yeah.
So everything you're saying is true, but I guess my real point is that the focus on climate per se is making all of that happen.
Yeah, well, I think as I said, I included in the good news that the bad news that the temperature is going to rise more for a doubling of greenhouse gases than we thought, but the aerosols are a huge effect. So you've probably heard of stratospheric aerosol injection. We can inject some sulfur into the stratosphere and we can cause cooling of the planet. And now that we're finding out all of these regional effects, but also farther term effects, we could actually, if we were very smart, we could tailor the injection to cool the planet at a uniform way and maintain our excessive civilizations and consumption and stuff for a while yet. But then you hit some other roadblock, right? So, maybe, like I said, the idea of replacing, like, electric cars is a perfect example. We've got 1.5 billion cars on the planet. Do we really need that many cattle? 1.5 billion, right? And when we go to electric cars, surely we're not thinking of building 1.5 billion electric cars.
Well, yeah, that's what they want to do. We want to do it all in Canada too.
Right. The thing is you know, we need people in governments and stuff that are actually interested in well-being of citizens and you know, using the best intelligence and knowledge from science, and you know, not being beholden to powerful corporations. I mean, there was an article about AI technology and AI stocks and AI investments, and it just added another $250 billion to the richest 10 people on the planet.
Yeah.
Right. So the inequality, you know, causes, of course, huge social unrest and turmoil. What I really liked about Lenton's document, you know, just have a read through, you know, just sections. I mean, it's an extensive document, but it does talk a lot about the human factors, like educating young people about climate change, you know, more and more young people in governments. I think we should have an age limit on governments. I don't think we should allow any politician to be over 60. Right? when you're 60, you're given your retirement package, you're out. Right? Politics and running of governments and countries should be a younger person domain, in the domain of younger people who actually care about the planet.
What would you say about this? The one final quick point. Gavin Schmidt, who's the head of the Goddard Institute of Space Studies at Columbia University, and NASA sponsors it. I guess he's next to James Hansen, my voice on climate issues. But in March, he gave an interview in which he said, and I quoted it in one of my posts here, "We really don't know what's going on. We are unable to reconcile our theories with what's actually happening." Exactly. So climate scientists have lost faith in their own models. Is that what we're saying?
Yeah, no, precisely, because the explaining of ocean heat temperatures in the last 4 or 5 years is like there's no science that can do that. But Hansen, I think the sulfur, and the Chinese paper, you know, I think these are really the keys, and the aerosols are super powerful effects on the climate, which was previously not recognized by mainstream science. So I went to the Ottawa Writers Festival about a month ago, and 2 of the speakers were Wynne Dyer, on his book is Intervention Earth, you know, all about the carbon removal and solar radiation management ideas. He's a great author, good book. Michael Mann has a new book, Our Fragile Planet or something, and his book, I spoke to him. He was also in Ottawa about a month ago, and his book is also excellent, you know, highly recommended for, you know, the history from paleoclimate to present day and what he thinks need to be done, because he's still been arguing until recently that our global warming wasn't really accelerating. It was meeting the models and so on. But I think he has to eat his words on that one. And I think he will very soon. Yeah, but basically, they're saying the same thing. Yeah, we haven't been able, what's happened in the last, say, 5-10 years is unexplainable by climate models. So the models are, and I'm trying to say is the models are wrong in 2 counts. The equilibrium climate sensitivity is much higher than the science has said up to now. And it's canceled out by the much higher aerosol effect. Mm-hmm. So you can have both numbers wrong and be much too low and have this, you know, be able to explain things up until, say, the last decade. But the stuff that's happened in the last decade, no. I mean, the acceleration from 0.18 degrees Celsius per decade to 0.36, doubling the acceleration, the warming rate, you know, since 2010, those sort of things are unexplainable by mainstream scientific models. By mainstream, I mostly mean the IPCC stuff. You know, and great, they're going to have another report in 2029. Right? You know, another 7,000 pages of documents, and you know, is that going to help us really? Like, I don't know.
No, is anybody going to be around to read it? Sorry.
Well, yeah, because we've got this SOS technology, right?
We can upload ourselves into the universe.
Yeah,
digital
we need
copies of ourselves all over the place.
You know, SRM is some accountant came up with solar radiation management. SOS is much more effective, I think. And we're actually up, you know, we're I mean, look, we're doing all of these all of these SRM stuff right now, inadvertently, reducing sulfur from shipping fuels, cleaning up the air over continents, right? We're having all of these effects on planetary warming in different regions, oceans, etc. You know, but we didn't, oh, well, we didn't know that was going to happen, right? Well, we do now. So, right, I'm just saying, if we are smart about it, then we could actually, I don't think we have any choice. I mean, it's not like it's super expensive. Like Bill Gates could put some money together and he could send up some balloons or planes and put sulfur into the stratosphere and cause a planetary change, you know? Like it's within the realm of multiple billionaires, basically, at this stage. So somebody's going to go and do it.
Great.
So we might as well be smart about it.
Okay, 2 quick observations before I pass over to James Desmond. David Pollock is on deck. The first one is we've actually been doing geoengineering for approximately 150 years. We just didn't really know it and certainly didn't plan it. And the other one is that, of course, every model is wrong. It's a model. All models are wrong. They cannot possibly be actual reality. And we always need to keep that in mind. But, you know, we're talking about technical fixes that are going to make this right. Oh, what could possibly go wrong? Almost
Well, it's not all or
technology.
nothing. No, it's just it's an iterative process. You just start doing something, tweak it, right? But we understand, you know, we need to have the right numbers on the strength of aerosols.
Yeah.
We're getting there.
Damon Shively has a remark, all models are wrong, but modeling is essential. I don't disagree with that. I just want to point out we should never expect a model to be 100% accurate. It's a model, cannot be that. Okay, so over to James Desmond and David Pollock on deck.
Thanks very much, Dave. Hi, Paul. Good to see you again. First of all, I want to thank you, Paul, for all you're doing. Your work has given us all, you know, the insight and knowledge, and more importantly, the ability to understand the intricacies of the science and systems, you know, fueling global warming and the ramifications if left unabated. By illuminating all of the work with your work, by illuminating all the other great people's works, which would have otherwise been inaccessible to us and to most of us. But you've developed, through your work, you're after developing an amazing following, and I'm one of them, and I have been for a number of years.
Well, thank you.
So, like, you've inspired me, to be honest with you, Paul, you've inspired me to be more than just a passive listener. For example, you may recall yourself, we first met in Glasgow at COP26 while attending Professor Yato's Reflection Project, SRM.
Yes, of course. Yes.
I was there, motivated into action, and by action I mean action grounded in the science, with a group of other friends, some of whom you may notice are here with me today. We were promoting Professor Stephen Salter, may he rest in peace. We were promoting Professor Salter's Marine Cloud Brightening project, amongst others, as well as people such as yourself, and we were noted in the British press as being the runaway success of COP26 as well at the time.
Mm-hmm.
So, a few months later, we actually recorded a video together in relation to marine cloud brightening with Professor Salter, whom I might add was brought to my attention in the first place by you, Paul. You may also remember the work we did in conjunction with the Indigenous nations through Kindred Spirits Ireland, and we continue to work with the Indigenous nations up to this day. My point, anyway, Paul, and I apologise to everyone for taking time now to get to it, but given what I've just heard here now as well, and about the, you know, as you said, there are some hopes about from the science that came out from the studies in China and the aerosols in China, that my point is that you were very instrumental in motivating myself and others into action, right? Inspired by your work and your amazing videos, which break down the barriers of scientific language for the average layman to understand. Just a small group of us were able to achieve all of that and more, which leads me to my question, basically. Given that a lot of us, due to your work, understand the nature of our shared predicament, but yet not enough understand it, what would you think of the idea of inviting your most engaged followers to go from passive listening to active participation, to take a step forward by inviting your followers to a Zoom space for a purpose of Q&A on the subject matter of your latest videos, for the purpose of not only giving your loyal followers a chance to get to know each other and start to engage in conversation, leading to peaceful action and or agency in such as doing studies into such as marine cloud brightening and the aerosols, because
Yeah.
I don't believe, I'm sidebarring here, no, but I don't believe
Yeah.
the answer. I don't believe the answer is putting sulfur, replacing sulfur, taking it out of the fuel, but putting it up into the stratosphere.
Putting it up by fire, yes. Yes,
Okay.
yeah, well, thank you for everything and all your
I
work.
just
And
finished
I think we should you know, get in touch after this video and talk about steps that we could do to get more people to take action that now that they know what's happening. So let's do that. I mean, there's Zoom Spaces, there's there's Twitter/X Spaces. There's many other social media platforms, Blue Sky and Threads and other things, which I've been meaning to expand to for a while, but I haven't done it yet. But I'll bump it up on my priority list, because there's different mechanisms where, you know, you can go even on Facebook where you can do live sessions. And I think I could start doing more of those sort of things, so I could interact more directly with people that, like yourself, who really want to take some action on what's going on. I mean, there's groups in Ottawa, you know, there's groups all around the world that are doing this. In fact, there was a group in Ottawa where 3 of their members climbed the poles over the main highway, and shut down traffic on the main highway on various speeds around Ottawa, and they were arrested for their work, for what they did. I mean, the article said they caused some accident, but there were no injuries. I mean, I don't know what the reporting, you know, we're in a world of propaganda. We're in a world of fake news, fake information. It seems to be getting worse and worse. It feeds off the natural human instinct towards biases, right? Being biased. And people, you know, they've done surveys, and the vast majority of people in Western countries fail to know the difference between factual statements and opinions. And this is a very dangerous sort of situation to be in when this is the case. So there's all of these different issues that we could address. So thank you. Yeah, so let's go offline, and you've got my contact information, my email, and so on.
I have indeed, but and I would love to do that and go offline. But if I may just finish just the premise of the question, and just for everyone else, I was just like, the idea of like inviting your followers to a Zoom meeting would be also for the purpose of your followers, not only to get to see you in person, so to speak, and answer some of your questions, but for them to engage in conversation that would maybe lead to some form of
sure. So just set up some forums, and invite me, and I'll send the message on Twitter and Facebook and that to all followers, etc. We'll get CACOR people, anybody else who wants to come on, and we'll go to it. I know, I'm not sure if Zoom's the right one, because people come on and they can hack into Zoom. I remember one CACOR talk I gave several years ago, and I posted, I think, it to some social media, and you know, we had to, it's like, it was just completely hacked, and we ended up starting like 20 minutes late because they had to create a new link for the talk. So you have to do things that are secure. Like, I think WhatsApp has some good secure things, and the Twitter meetings seem to be working fairly well. You can get large numbers of people on Twitter asking questions. It's interactive and live. So there's lots of forums. Just set up stuff and invite me, and I'll show up to them.
Excellent. Thank you very much, Paul.
Okay, thank you.
Great, thanks. Okay, so I believe that David Pollock has left us. I'm going to pose his question very quickly. You should be able to get through this in a minute or so, because I think you may have covered it. And John Legg is on deck. So what David Pollock wanted to know is that you mentioned the AMOC collapse, possibly in a decade or so. He wanted to know if that's the best estimate on the timeline.
The estimate on the peer-reviewed paper that talks all about the timeline of the collapse It said it could happen as early as between 2025 and 2090, I believe. That's quite a range. So,
Yeah,
I guess
the model's just not good enough.
no, it's just not. It's not. And we really, this is a question I think that's best answered by looking into the paleo record data in detail on that specific question. If you see these warning signs, how long, and also I think monitoring the global warming hole is a very important thing to do.
Yeah, great. Okay, thank you. We'll go over to John Lake. I've got Melissa Koch on deck, and we may well wrap up after her.
Okay, Paul, a fantastically dense presentation, which should be reseen. My question is, in your listing of the good, bad, and ugly, especially the bad and ugly, I did not hear any mention of the two longtime fears of two juxtapositions. One is methane thawing, and then of course thawing leads to more emissions, etc., etc. So there's the vicious circle there, and loss of albedo or albedo. Now, the second one, of course, is pretty well already out of the bag. That is to say, you lose ice cover, which gives more warming, etc., etc. So what about those? I know that the IPCC actually said no, you can't use these things which haven't been in effect yet. No, you can't use them. Well, that's a lot of bull, pardon my undiplomatic vocabulary, because it's sort of obvious that they will feed upon themselves. So anyway, comments, please.
Yeah. So a thing about the terminology. So we can talk about feedbacks, right? Like the albedo feedback, for example. You lose ice, it's become a darker surface, it absorbs more sunlight, warms, lose more ice. So the feedbacks that are reinforcing and causing something to increase in strength, those we call positive feedbacks, right? But positive means good to humans. It doesn't mean something, a positive feedback is something you don't want in the climate system. Negative feedbacks would slow down something, and they'd be kind of like braking or moderating feedbacks, if you like, to slow down something happening. And, negative, of course, is a bad connotation, but a negative feedback is good. So this global tipping point 2023 report, it turns it around and it says, let's talk about positive tipping points and negative tipping points, where positive and negative are in the normal human association for those terms, right? So they change it, and they do have a whole section where they talk about the feedbacks. Now, in terms of the, a tipping point is actually quite different from a feedback, right? I mean, there's all kinds of feedback loops in society. You go to school and you get bad grades, that's a negative, that's a feedback to get you to work harder to get better grades, right? So there's feedbacks in everything. So the albedo feedback, of course, is a very powerful ongoing one, which affects polar warming and polar amplification. The methane thing, it's interesting because the methane thing has been a big concern and still is a possible big concern or wild card. If the Arctic continues to warm at accelerated rates, there's more and more permafrost thaw, there's more and more methane released, which can then feed back and cause more and more warming. But it's not all feedbacks are necessarily tipping points. I guess the thing is, the paper that was arguing that we still have Arctic sea ice because of the AMOC slowing down 30%, right? That's a very significant paper because, if the Arctic warming is put in check by the ocean currents, then that again greatly reduces the risk of methane coming out in huge quantities from the Arctic region. Okay, so that's a feedback. That's a case. Not all tipping points interact in negative ways with other tipping points. Some of them, like the Arctic significantly cooling or warming kept in check by slowing ocean currents, it stabilizes the methane up there, but it also means that the risk of huge calving and lots of ice collapse from Greenland glaciers is reduced. Right? But then by the same token, we have this, call it a seesaw oscillation. And if we look in the paleo records, there were times when the Arctic warmed greatly and Antarctic cooled greatly, and vice versa. It was like a seesaw sort of thing going on. So there's lots of complexities. We can never assume we know everything about the climate. As soon as we assume that, then we know that we're not looking deep enough, because if I get, if you look in my talks from say several years back, things are different. I mean, what's happening on the ground is different now, so we have to kind of be humble a bit and just try to figure out things as best we can.
Right.
Right.
Okay. I just would make a quick reference to, you mentioned, I think, having to do with terminology and then examination marks and so on. It makes me think of the young boy who's commenting on his own report card, which he's handed to his father, and he says, "Just remember, F stands for fabulous." Anyway.
Yeah.
I couldn't let that pass.
So
exactly.
Paul,
you.
your last comment brings to mind, we've never done this before. I don't know how we could actually predict that we ought to know what's going on.
Yeah, exactly.
Never happened before. Okay, over to Melissa, and then we're going to go to Ted Manning for a thank you.
Thank you so much, Dave and Paul. I actually didn't have a question, but the spirit works in funny ways, synchronicity. So I always want to mention Mother Earth. I know as scientists, you don't like the term mother, but she is a living entity, right? And the focus of so much of my work as a visual artist is environmental justice and reminding the human species of all the other sentient beings or species we share the planet with, and that we really have a responsibility to them to cool the planet. So Paul, thank you so much for this incredibly informative, beautiful work you're doing. I know that we are so enthusiastic to get your voice out to an even wider public, because so many people around me aren't aware of things like solar radiation management or what's really going on, and all the camouflaging that happens. And I love I'll call it a philosophy, or your ideas about changing our lifestyle, because that's so much behind also the changes or the transformations that humanity has to make. So I really see this as a great spiritual transformation of our species, or evolution. I guess you'd like that word probably better.
Yeah. Well, thank you very much. Can you tell? Did you do the art behind you?
I did, yes.
And is she holding the? I could only see one side. I thought she was holding a bow and arrow, about to shoot an arrow at something, but no, it's a circle, right? So
holding the hoop, the global hoop.
Yeah.
And,
okay. Okay.
Really referring to our connection to all species. There are also some salmon jump. I don't know if you can see the salmon in this. You don't see the whole painting.
The pelican and
that's
yeah.
a heron, because we live in the Pacific
Northwest.
So.
Yeah. Well, thank you. And this brings a very important thing, that communicating to people through art, through fiction books on climate change, and not as what are very just as important as any of the hard science things, like just to get to people's hearts.
Right, absolutely. And I think that could be a beautiful collaboration between all of us as well. Yourself, myself, all of us here, let's do some really cool projects. In fact, we got legislation changed here, working with children to protect the Chinook salmon for the orca populations. And so it can be effective, right? Working with politicians.
Yeah,
and
very,
policy
I mean,
making.
I'm doing some work with for climate risk assessment for some First Nations people in northern Manitoba. I'm doing some work with some Hollywood screenwriters on a fiction book, which they want the climate stuff accurate, make 5-10 years in the future. Some other authors I've been doing some work with also on climate fiction. So, the more, whatever can get people to pay more attention is good, I think.
Thank you so much.
Thank you.
Thank you. Behind me, you can see the 3 climate fiction books that I published. We're going to go over to Ted Manning now for a thank you.
Oh, delighted to have you aboard, and all of the rest of the people here, because every one of them pretty well is from a different discipline. I'm a geographer, and I'm a acolyte of Gaia, I guess. And because more we look at this stuff, we realize how interrelated everything is from every discipline. And when you talked about modeling, the kind of stuff that we were doing a few years ago with IASA was to try and understand how you could model the kind of complex futures that you've been talking about here. And Rob Hoffman, when he was with us, did a lot of that too. And the one thing we could come up with was the concept of not impossible futures, and to look at the implications of what each might bring acceptable and livable futures among the kinds of ones you could model. So that was something that we were able to use, at least to get the attention of some politicians who wanted to figure out if there were futures that they could work with. These days, it's getting less easy to do so. And Bill Rees said it best, which is essentially that we've got to change our behaviors and our consumption patterns. And really, if we don't handle overshoot, the other symptoms, even though climate is a very vital one, will be moot. We can use all the modeling we like, but if we don't stop eating ourselves, ain't gonna do good. So I would thank you very much for stimulating a superb discussion. We've been very lucky of getting some of these going. We've had several over the last few weeks, and in fact, of a lot of thinking happening on the air, and I'm hoping we can continue doing this. So I'd like to thank you again on behalf of CACOR, and to tell you that we do benefit from having all of you come. For those of you who are members of CACOR, please continue and pay your dues. For those of you who are not members, please join us, because that's what makes this happen. And that's what makes it happen with more and more people and more watches every time we put it out. Some of our YouTubes are in the thousands now once these get out there. And we see this as a way to stimulate conversations that can help us all. So thank you again. If you watch our YouTubes, please subscribe. And I hope you all have a very nice future, but I can't model it.
Well, thank you. Thank you, Ted and Art and everybody at CACOR. And I'll have to come back on in another year or so to say exactly how I was completely wrong in this talk today.